So now we're getting into circle trig. Why would we need circle trig? Well, because up till now, if I asked you for the sine of 100 degrees, you'd be like, well, you can't make a right triangle with 100 degrees in it, so you can't get the sine of 100. But you can. There is a way to get sine of 100. All right. I'll show you how in today's lesson. You're going to be talking about periodic functions. That just means things that oscillate, like back and forth, like this one. Does anybody recognize which graph that is? That's the graph of sine. Yep. And cosine's a lot like that. Cosine's just like this, except it's shifted over. So it starts up high, and then it goes down. And then cosine kind of does something like that. I did pretty bad on that one, but it oscillates anyway up and down. The 16-point unit circle, okay, that's the circle trig thing. We're going to talk about that. And basically, by doing this, you can get to a lot of other real-world problems that don't have triangles in them because they have circles in them. All right, so there's a lot of trig that you can do with circles. All right, some terminology. You need to remember that the initial side is where you start and the terminal side is where you end. Terminal cancer, probably the end of your life, because that's what the terminal is supposed to mean. Yes, people do sometimes beat terminal cancer, but usually they don't say terminal unless you're in a really, really bad spot where you're probably not going to live. So it's the end. Get terminal's end. Initial is beginning. All right, so if in all of these problems, this red line is like where you start here, where the red and blue line are on top of each other, that's called the what side? Initial. And then wherever I stop, that's called what? Terminal. And again, you were fine with finding sine of 90 or 45 or, no, not 90, sorry. Anything between 0 and 90. You were like sine of 10, you could do that. Sine of 20, sine of 45, sine of 80, okay? But as soon as we go past 90, you weren't able to do sine of or whatever anymore. All right, so let's make this scenario right here where I've gone that far. Now just move this over for a minute. I'm not doing a point right now. I'm just saying, let's say this angle right here was 160 degrees. Then right away, I want to figure out how big that angle is, because I know that that's kind of important. But can you tell me how big that angle would be? Well, the total is 180, so what's that last little piece? 20. All right. I know you know that you can't do sine of 160. At least you couldn't until now. But do you get that you could do the sine of 20? What would the sine of 20 be? Well, sine is opposite over hypotenuse, so I just need to know, here's my triangle, right? I need to know how long the sides are, and I could do sine of 20. Or I could just take my calculator and type in sine of 20, and it'll tell me the answer. Why don't you do that? Take your calculator, type in sine of 20. Make sure you're in degrees. It matters. Some of you will be in radians. Make sure you're in degrees, go sine of 20, and what do you get? Point what? 3.4. Okay. So sine of 20 is 0.34. Now I want you to do sine of 160. Ooh. What's my point? They're the same thing. So if they ask you for the sine of 160, what you should do is not figure out the sine of 160. You should figure out the sine of 20, because it'll be the same exact thing. Do you get how I can't draw a right triangle with the 160 degrees in it? But I can draw a right triangle that has a 20 in it. So if I want to know the sine of 160, it's the same exact thing as the sine of 20, because they add up to 180. Will other numbers work for this? Absolutely. Think about this. Sine of 110. What would that be the exact same as? Sine of 70. Try it. Sine of 70, sine 110. I just want you to verify. If you try it a couple times, you'll get that they are the same thing. So sine 70 is like 0.93. Sine of, what's the other one that goes with that? 110. 0.93. Okay, so that's one way you can kind of cheat and do sine of any huge degree. In fact, we can even go crazy with this and say, what's the sine of something that's bigger than 180? Like, watch what happens when I do this. You get that's 180, right? Because it starts over here, so that'd be 180. What would that be about? Sine of what? More than 180, but 200 maybe? Can I say it's about 200? At about 20 degrees? Okay, so if that's 200 degrees, what do you think I'm going to use now for my reference angle? That little angle right there. It has to be less than 90 or it can't draw a right triangle. So instead of 200, I would use what? 20. Prove to yourself using the calculator that sine of 20 and sine of 200 are the same thing. 200 degrees and 20 degrees. Are they? Oh. One of them's negative. There was a negative, you just didn't see it? Yeah. Okay. All right. So we can have negative answers now? Yes, you absolutely can. Let me show you the reason you can have a negative for sine. Sine's always been opposite over hypotenuse, and we always did triangles that were in the real world where the sides were always like positive, right? All of our triangles, in effect, were over here. Where if I make a point like right here and say it's 1, 1, then this would be 1 and this would be 1, and this is actually one you know. That's the 1, 1, and what? Square root of 2 triangle. And then this must be a 45-degree angle. Do you get that? All right, we always were doing triangles over there where the sides were always positive. Guess what happens when I draw this over here? And this is still 1, 1, and square root of 2, except, get that out of there. This is negative 1 and 1, and the square root of 2. Do you get why that's negative? Because if I'm going from here over here, that's to the negative direction. Okay. So now if I'm going to do an angle, let's say I do sine. If I do sine of this, it's still positive because it's opposite over hypotenuse. And this one, sine of theta, would be 1 over the square root of 2. But now if I do something else like cosine, it's going to end up with a negative answer. You've never had that before. Now that's possible. Cosine of theta. Cosine is ca, adjacent over hypotenuse. The adjacent side is negative 1. The hypotenuse is square root of 2. Negative 1 over the square root of 2. Your answer should be negative for cosine. All right, so you've never had negative answers before. Now you have. You've never had angles more than 90. Now you do. So again, if I want to make sure you didn't forget that first point. Let's say I asked you to find the sine of 170. What would that be the same as finding the sine of 10? All right, so that's called a reference angle. This is the whole angle of 170. The little angle that's left, the 10-degree one, that's the reference angle. It's almost like we'll cheat and use 10, even though you really want the answer of 170. But the reference angle gives you the same answer. All right. Next thing. You'll need to understand if I put a point on here, put that back to the same spot. That's the, which side is that? The blue side there? Is that the initial or the terminal? That's the initial, and this is the terminal. And let's say I have my terminal side end up like about here, and that's the one where it's going to be a point. The point negative 1, 2. Do you get that when by telling you that, I just told you two sides of a triangle? What's this side down here? Negative 1, and this side? And then this side in your head, figure it out. Who's fast at that? Square root of something. Square root of 5. All right. So now, let's say I asked you for sine, cosine, and tangent of this angle. Well, that'll be easy now. The sine is opposite over hypotenuse, which would be 2 over square root of 5. So sine of theta is 2 over square root of 5. The cosine of theta is chi adjacent over hypotenuse, negative 1 over square root of 5. Notice I have a negative answer in there. And last is tangent of theta. Tangent is TOA, opposite over adjacent, 2 over negative 1, which is the same as negative 2. But all right, so I just found the sine, cosine, and tangent of an angle based on me just giving you a point. I gave you a point, and in effect, by giving you that point, I also gave you an angle, and I gave you a triangle, and then you could make a trig problem out of it. Yes, sir?
So for this unit, are we not, like you can't, real world problem,
You can't use negative lengths for a side? Yes, you are correct. But in this context, we have to use it as negative. I know you're thinking a distance can't be negative, but then think of it as a place on a graph. Since you've been graphing for a long time, right? And stuff in here was at like 2, 2, and stuff here was at like negative 2, 5, you know what I mean? And stuff down here was at negative 3, negative 3. That was okay in that world, right? So think of that world. Yes?
Why would it not be a square root of 3?
Square that for me. What do you get?
4.
Square this for me. Okay, you're thinking that it had to be 1 and 2 in the square root of 3. That's a different kind of triangle. That's if it has a 30, 60, 90 triangle. This is not a 30, 60, 90 triangle. If it had been, then you're right, the numbers would be different. Grace? Grace H? Come on up. Okay. So, I've taught you about finding a point, and a point will give you a couple sides. I've taught you about if they give you this angle that's bigger than 90, that you should use the reference angle that goes with it. Next, I got to talk to you about sides that are called coterminal. All right. Now that you're in a circle, all kinds of crazy things are possible. Do you get that this is about 30 degrees? Don't argue too hard. I'm trying to make it 30. Does that seem about like 30 or so? Okay. So if that's 30 degrees, I could put the 30 degrees right here. Sometimes we do that. And then if we say that there was a 30-degree angle, do you get that I could have said it was also pi over 6? And that's just measured in what? Radians. You are going to need to know those radians really well. Like, you're going to need to have them memorized. Like pi over 6, you're going to need to know, oh, that's 30. You really, really need to memorize these. So I'd like you to make a list right now. Make yourself a nice, clean, big circle. Big enough, because we're going to write a lot of junk on this. I'd make it a whole page. It's kind of like a unit circle, but it's not the unit circle. But yes, unit circle's huge. And you may have learned it in a different way. I think I've got a way that's pretty easy to memorize all these spots on the unit circle. All right, so if that's 30, which is pi over 6, this would be what? It's about 60. Now, what I don't want you to say is that that's pi over 3, because here's why. There's a way better way of memorizing all of these than trying to memorize these random things like 2 pi over 3 and 5 pi over 7 and all these crazy things that are in there. I think you're going to catch on to the pattern really easy. This was 1 pi over 6 down here. Would you agree I could put a 1 there and it'd be the same thing? Take a wild guess what an angle that's twice as big as it would be. 2 pi over 6. See how that kind of just flows naturally? And yes, that can be reduced, but it's smarter not to. It's smarter to say, okay, that's 2 pi over 6, because then what's the next logical one? 3 pi over 6. If I go to 90 degrees right here, make that 3 pi over 6, it works. 3 pi over 6. Now I know that can be reduced. What can be reduced to? pi over 2. But that's okay. We're not going to reduce that because you got to memorize a whole crap load of these things, and it'd be way easier to just know that, okay, it goes like this: 30, 60, 90. You can count by 30s pretty easily, right? After 90 comes 120, then 150, and then 180. Those will be easy. But how about these radian ones are crazy. If you'd memorize them the normal way, yeah, they jump all over the place. It goes pi over 6, and then it goes pi over 3, and then it goes pi over 2, 6, 3, 2. That doesn't make too much sense. The next one's even worse because I'm not even going to do it that way anymore. I'm going to keep doing it the red way. If I go another 30 degrees, take a wild guess what it's going to be. 4 pi over 6, see? And yes, I could have written that the green way and say 2 pi over 3, but it would be way harder to memorize the green ones. So don't. Memorize the red ones, and it's going to be a snap. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. What's coming next? At this spot right here, it'd be have what? 5 pi over 6. And it even works here because it'd be 6 pi over 6. Technically, what's that reduced to? Just pi. Get how the 6's could cancel? But you don't want to do just pi because then you won't know what to count to next. 4 pi over 6, 5 pi over 6, 6 pi over 6. What's this spot? 7 pi over 6. Next one. 8 pi over 6. Next one. Come on, am I the only one going to count by ones? Thank you. 9 pi over 6. Next one. 10 pi over 6. Okay, fine. Since only one person's answering, I'll do it myself. And this is 12 pi over 6. And what's that the same as? 2 pi, which is the same as 360 degrees. If I was going to label this with degrees, I'd say it was 0 degrees, or 360, or 12 pi over 6, or 2 pi. Those are all called coterminal because there are a whole bunch of names for the same angle. 0 degrees and 360 are exactly the same thing. They're in the same spot. So if you do tangent of 360 or tangent of 0, you'll get the same answer. Do you get what I'm saying? All right. So again, you just count by 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And it can't be that easy. Well, it's not. Because that's not all of them. That covers the 30s, the 60s, and the 90s. Which ones didn't we talk about? The 45s. So you have to memorize those too. But same deal. If once you start counting by them, it's not that bad. That spot right there, got it memorized yet? It's 45 degrees, also known as pi over 4. Good. If that's pi over 4, think of it as 1 pi over 4. What's the next one? 2 pi over 4, also known as pi over 2, just like it was before. It's still pi over 2. It just reduces from a different fraction to pi over 2. But 1 pi over 4, 2 pi over 4, these are the 45 degree ones. This one's the next 45 degree spot. 3 pi over 4. 4 pi over 4, which makes sense if you think about it because the 4's will cancel and it's just pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4, which again makes sense because it reduces down to 2 pi, which is 360, which is the same as 0, and it all makes sense. Now, why do you have to memorize all these? Because we're going to do tons of stuff with them. The first thing today is they're going to say, like, is sine positive at 5 pi over 4? And then you go, where the heck is 5 pi over 4? And if you know how to count up from 1 pi over 4, you can go 1, 2, 3, 4 pi over 4 and get 5 pi over 4 right there pretty quick. And now, is sine positive there? If I made a triangle using this, I would use the reference angle right there and say, is sine positive there? Well, this is a negative number, like -2 and -2. And if those numbers were the same, because it's a 45, 45, 90, right? Let's even use 1, because then I think you might recognize it. -1, -1, 1, 1, and what? Square root of 2. See how that doesn't go away? You still got to know that. Then, by the way, is that square root of 2 positive or negative? It's positive. The hypotenuses are always positive. All right, so then I asked the question, is sine of 5 pi over 4 positive or negative? Well, if I do the sine of this reference angle, sine is the opposite over the hypotenuse. Do you get that there's a negative in the answer? So sine is negative at 5 pi over 4. All right. I do want to remind you that if you're like stumped on one that's like 5 pi over 4, I don't know what that is, and you want to change it to degrees, you can. You're going to multiply it by either pi over 180 or 180 over pi. Remember this way? That works. So I got to go pi on the bottom so it cancels, right? And then I go, here's the problem. I got to do 5 times 180 and divide it by 4. Wouldn't it be easier to memorize them? Yeah, you're going to have to do that a ton. And if you just memorize that 5 pi over 4 is in this circle somewhere, and 1 pi over 4, you got to memorize the simple ones. If 1 pi over 4 is there, you go, oh, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is down here. 5 pi over 4. Okay, a lot of stuff. This is the part where I think I've taught you everything you need to know to be able to do the homework, but I taught you so much stuff that I think you might start the homework and immediately feel frustrated, and so I'd rather do the first few problems with you. So, to begin with, I'm not going to ask you to go get a book. I'm just going to tell you at the first, like one of each kind of homework problem. We're going to do one together. You could start the assignment with that, and then you can just skip those as you go through the assignment. Your assignment's going to be page 381, 1 to 20. Page 381, 1 through 20. I had a 20 through 24 originally, but I decided it was too much for today, so I'm backing off to 1 through 20. All right? And let's do number 1 together. And again, I'm going to read it to you. So here is numero uno. Please write these down. You're going to write them all down and cross off one of them that doesn't work. 150, 510, negative 210, positive 450, and the last one is positive 870. It asks, which angle is not coterminal with the others? Now they used like a double negative there, so I can ask the question a different way. All of these are coterminal except one. Coterminal means that they're in the same exact spot. Can you name 2 of these angles that are the same exact thing? Picture the circle. Picture where 150 would be. Do you get the 150 be like right about there? Because it's a little less than 180? Okay, so which one is the same as that? The negative 210. Do you know why it's the same as that? Because when you go from here, I got to get my nice circle back. Where'd he go? Let's see if I can do this fast. Yes. Then, if I go this way. Did I tell you this, that these are negative if I go this way? Okay, so if I go down here and that's like negative 45 to right there, this would be like negative 90. This would be like negative 180 because I went that way. And this would be like negative 210. You get that? All right, so back to my problem here. So negative 210 and 150 are the same. This is the same as this. So that means that's the one. And one of those is also like 2 more of those are the same thing. 510, how do you know that? Can you prove it? You take the 150, you don't subtract. You take the 150 and then add 360 to it. It's like you go here and then you go 360 degrees more, 360 plus plus 150 is 510. Yes, that is the same. That's coterminal also. 870 also works because why? Add 360 to this, and you get this. So obviously there's only one that's left, and so that one's the one that's not coterminal with the others. Cross off the 450. Okay? That's one type of problem. It's like which angles are coterminal, which basically means the same. And most of these were the same. One of them was different. Okay. Next kind of problem is like number 3. You might want to draw this little picture for number 3. It's got your circle. This is circle trig. You're going to have lots of circles and lots of triangles. Okay, next they give an angle that's right here. Let me see how steep is it. It's about like this. And then they say that there's a point on that that's at -1, 2. -1, 2. By telling you that point, do you get that they just gave you 2 sides of a triangle? Draw this triangle, and I bet you'll figure out what the 2 sides are. Well, this point is at -1, which means I went over 1. See, that's -1. And then up 2, which means that's 2. When they're giving you a point, they're really telling you directions, like go to the left 1 and then go up 2. All right, so it's -1 and 2 are the 2 sides. And I know some of you are bothered by the fact that that's negative, but you're going to have to just deal with it because it's important for you to understand your answers now. It didn't used to be able to be negative. It can be negative. All right, and then what's the third side? Well, if I take -1 squared, it's going to be +1, and 2 squared is 4. 1 and the 4 makes 5, so what's the answer? Square root of 5. So this one's square root of 5. And now what do they want on this problem? They want to know what all 6 trig functions are of theta. And theta is this, but we're not going to use this. We're going to use this because it'll give us the same answers. Remember how the reference angle gives you the same answer as the big angle? Okay, so draw a little theta right in there, and then all you have to do is sine, cos, sine of theta, cosine of theta, tangent theta, and what are the other 6? Cosecant theta, secant theta, and cotangent theta are the 6. Now, this should be easy for you. Now that I've drawn the triangle, it should be super simple. Sine, opposite, 2 over hypotenuse, square root of 5. 2 over square root of 5. And now it's just like the problems we did before. Cosecant, you just flip it. Square root of 5 over 2. Cosine, cosine's adjacent over hypotenuse. Adjacent is -1 over hypotenuse of square root of 5. And secant, you just flip it. Get what I'm saying? Once you've got the triangle, the rest of it's just like we did before. All right, so there's that kind of problem. Next kind of problem is like number 7. Everybody skip to number 7, please. And they just give you a point, 3, 4. This means the point is 3, 4. Can you picture, using the circle, where that would be? Over 3, up 4, over 3, up 4. It's like that. That spot right there, 3, 4. Do you get that they really gave you a triangle by giving you that? You got to be able to see these triangles. Triangle here would be there. And its sides are 3 and 4. And if you have this one memorized, it'll save you some time. 3, 4, 5. Yes, that must be 5. So now, this is theta. They once again want all 6 functions. So sine of theta is opposite over hypotenuse. Opposite is 4. Hypotenuse is 5, 4/5. Cosine is adjacent over hypotenuse. Adjacent's 3 over hypotenuse is 5. Get the idea? Once you get the triangle, it's easy. Yes?
For the last two, you really needed to use the circle. Will that come later on?
Yes, because in the next question, like number 8, number 8 gives you -4 comma -6, which means that we're going to have to go around my circle technically all the way until I get to a point down here. That's going to be at -4, -6. Actually, I should have gone a little farther down, like down there. And the circle part, I'll just say this, the circle part's going to be more and more important. Right now, we know you're still used to triangles, so we're trying to turn all the circle problems into triangle problems. So by giving you this point, -4, -6, now again, I've got a triangle. And you're right, I don't really have to have the circle here, but what's going to happen a lot is that you'll know the radius of the circle. It'll be like given to you, and that tells you one of your sides. So it doesn't come up that much. It comes up in a few of the problems. The one I gave you isn't even a good example, but okay, anyway, let's move on to one more kind of problem that there is. Number 13. Number 13 says 0, comma, pi over 2. That is not a point. That is an interval. That's saying from 0 degrees to, you guys know that pi over 2 one? 90 degrees. From 0 degrees to 90 degrees. They want to know, are sine, cosine, and tangent positive or negative in this zone? They use t for some reason. Cosine of t. Just copy what I'm writing. Now, I'm going to draw a little picture so you can see where we are. Do you get that between 0 and pi over 2 is in this zone right in here? Are sine, cosine, and tangent going to be positive? Well, yeah, because if I make my sides on this, anything in this quadrant, any triangle I draw in here, all the sides are positive. Get what I'm saying? If all the sides are positive, of course, sine of 2 positive sides, you'd have opposite and hypotenuse, are going to be positive. So this is positive, and that's positive. That's an easy one. All of them are positive. Let's just look at a different interval. Let's say the problem had said between pi over 2 and pi. Well, where's pi? Pi's right there. And here's pi over 2. So in the green zone here, do I have some negative numbers involved? Yes. So the question would be, is sine positive in this zone? Is cosine positive in this zone? Is tangent positive in this zone? And if I draw myself a little triangle and label it with some imaginary spots, do you get that this is negative, like -1, and this is like +1, and this is also, remember, this is always positive. And let's see if it's a 1, 1, this must be square root of 2. I've just labeled it with some imaginary numbers so that I know whether it's positive or negative. Now, if I'm using this triangle right here in the green zone, sine is these two. That's still positive, isn't it? So sine is positive in that little zone. How about cosine in that little zone? Cosine is adjacent over hypotenuse, which includes a negative. So cosine's negative in that little zone. And tangent is opposite over adjacent. That's this over this. Tangent is negative too. So only sine is positive here. And I have a shortcut for you to remember this by. Where things are positive and where things are negative. All of them are positive here. Only sine is positive here. Only tangent is positive down there because there's 2 negatives, and when you divide the 2 negatives, it ends up being positive. And only cosine is positive here. And there's a way to remember that. All students take calc. It's kind of dumb, but it could work for you. So now, if I ask you, in this zone here, what are sine, cosine, and tangent? Well, you'll be able to say, well, the only one that's positive is cosine, and so sine's negative, cosine's positive, and tangent's negative. The only one that's positive is cosine. Here, the only thing that's positive in the blue zone here, the only thing that's positive is tangent. All right, so that little, what's that called, a mnemonic? That little mnemonic will help a lot. A lot of the papers that I end up seeing when, like, I look at the tests, kids will have this little thing drawn in the corner of their test because they're trying to figure out where is cosine negative. And it can be confusing. Now, I've just told you, like, a ton of stuff about circle trig. Like, if you could just process everything that I've just tried to explain to you, you'd be almost through the first test. Okay? But I told you so many things I don't expect you to understand them totally yet. Now, there are a couple more things on the test than this, but this is a lot of it. Yes? Yes, so that if the question was, do you always use the angle that's towards the center of the circle? Yes, that's called a central angle. And if I had an angle that was like this, I wouldn't use the big one. I would use the small one here. Get what I'm saying? I'm using the reference angle. I wouldn't use this big one. Bad. I'd use that one. Okay? So if I drew it this way, it would kind of be important to know, did I go this way to get there? Because then my answer is negative, let's say 30 degrees. Or did I go this way to get there? And then that's positive 330 degrees. But they're the same thing. Positive 330 or negative 30 are coterminal. They're in the same spot. And the angle, do you get that it's going to be this angle right there? It's always the angle. It's right by the center of the circle. Yep. And you always make a little triangle. Okay. There's one last kind of problem, but I'm feeling like, yeah, I better show you, because if you're really that burned out, you can always go back and look at this later. Question number 17. Go do one more of your homework with me. Number 17. Yeah, it's a free answer. I got that going for you. It says cosine of 143. Well, right away, I want to know where that is. So I'm going to go off to the side and draw a little picture and say cosine of 143 is kind of like if I had a 143 degree angle, it'd be like this. But I'm not going to use that angle. I'm going to use the other angle. This one, right, would that be? It has to add up to total 180, so 37. So it's really asking me the cosine of 37. Get what I'm saying? And the question is, determine the sine of that without using a calculator. Sine meaning, is it positive or is it negative? Now, do you remember the little rule I just told you? You see how you might find that handy? All students take calc. What one is positive in this quadrant? Sine. And therefore, when they ask me for the cosine of 143, and all they want to know is it positive or negative, what do you say? It's negative. Neg. Done.
Oh, is that rule is that it's negative?
No. The only one that's positive is sine. All of them are positive here. Tangent is positive here, and cosine is positive there. And by the way, if you ever are asked for like secant or cosecant, those are exactly the same as their evil twins, because like remember sine of theta goes with cosecant of theta. Well, if I have sine of theta is positive because it's like two positive numbers, 7 over 2, do you get that cosecant has to be positive also? See what I mean? They go with their evil twin. So if I have secant, cosine of theta is like a negative. If cosine of theta is a negative, I know right away that the other one that goes with cosine, which is secant, that's got to be negative. Because if this is like negative 1 over root 2, then this one's got to be root 2 over negative 1. All right, you learned a lot of stuff. We'll see how much of it you can retain until tomorrow. Don't expect you to be perfect on this yet, but I do expect you to do your homework. It's problems 1 through 20. And we have about 10 minutes left. That's too much time to just sit there. So please come borrow a book, leave a shoe. Got them nicely organized on the shelf right there. A shoe or a cell phone is fine.